2. All right, there we go. Recording is on. All right, so in this most wonderful edition of ENGR210 F, not L, we are going to be kind of talking about why the heck we care about loops, which in large part are these things called arrays. So let me pull this guy over here. There we go. Okay, so we've made loops. Loops are great. They can let us do a whole lot of different things quickly, efficiently, and in a scaled way. I mean, think of the factorial calculator. You don't have to write out 4 times 3 times 2 times 1. You just make a loop. It does it all for you in three lines of code. It's awesome. It's called when things get more complex. Say looking at the Catalan number generator. Again, it's the same thing, just 3 different times. So you just run all those together and you're done. It's called the atmospheric conditions calculator. Instead of sitting down there and punching in numbers for each specific altitude, you just set up a loop and it does it all for you. Loops are awesome. However, we're now churning out a crap ton of data, especially for like that pressure and temperature thing, right? You're churning out at least, let's see, I said every 2,000 feet. So that's like 26, no, so that's like 32 data points, right? You're churning out a lot of information. That's actually a relatively small amount compared to, say, a numerical analysis code. Like when I was writing my master's thesis, I was putting together a wing analysis code. Each iteration of the loop would operate on around 6,400 points, and then it would grow each time through the loop. So by the end, we're talking about tens of thousands of points that this code has to iterate through. There's no way I'm going to do that by hand. There's no way I want to do that by hand. So in addition to these loops, we're also going to want to handle, we're also going to want to work with these data types that can handle more than just one piece of information. So if I have an integer, I have a float, whatever variables that we've worked with so far, I can put one thing, right? One number, one word, whatever. I can put one thing in it. Arrays, you can put a lot of stuff into it. It's where all this starts to get interesting, if you will. If it's not been interesting already, just wait, there's more. So we're sort of gonna talk about arrays. But in order to get there, I put a couple files on Canvas for you. If you wanna grab them so you can follow along with some of the examples. They're in the arrays module. I should have 2 text files there. I think one is well-log.txt and another is like NREL data or NREL 5 megawatt data. So you want to pull those down and put them somewhere where you can find them. Once you got them, you should see something that looks like, wait for it. Something that looks like this for the NREL data. Just a text file, bunch of bunch of numbers, has a column of wind speeds in meters per second, and this is for a 5 megawatt turbine. So it also has a column of power production. So you should see something vaguely looks like that. That's for the NREL one. The well log is a little messier. Looks vaguely like, wait for it. It's an obnoxiously big file. Something like this. A whole bunch of header followed by a crap ton of numbers. Cool. All right, so this is a well log. If you don't know what a well log is, It's called you got a well, you want to know what's there, right? So they send a logging device down the well. It has a variety of different instruments on it. Has a radioactive source, temperature, pressure, what was called a whole, I think there's a water saturation sensor on there. There's a whole bunch of different things on there. And every half a foot, it records a value for a whole bunch of different parameters. And it does that for the entire depth of the well, or 2,000, in this case, a 2,630 foot deep well. Every half a foot, that's like 5,200 data points. I don't want to touch that without a computer, right? So this is this is a really good example of like why you'd want to, like why we want to start messing around with loops arrays, loops and arrays for data for data analysis. This is not the only way to do it, but it's a really handy way to do it. So these are the two files that we're going to be working with. Right, does everyone have them in a place that they know where they are? Great. Okay. Now in Spider, go over to your scripting window and pull up a new file. It's called, once you have it up, go to File, hit Save As, and save it in the same place that you put these text files that they just downloaded from Canvas. What we're going to do next is open those files, those text files, in Python, and the script and the text files have to be in the same place in order for you to be able to do that. If they aren't, it's not going to work. So once you got that, great. One other thing that we're going to do, if you pull up the well log file, pull up in a text editor, either Notepad or Notepad++, or whatever floats your boat that can modify text. You can even open it in Spider. Scroll down to where you get this header line, where you have depth, CILD, CNDL, all those things. We're going to delete all the text above that line. So there's just that line of text, and then a whole bunch of numbers. So get rid of everything above that. You do not have to do that in order for what we're going to do to work. It just makes our lives a little bit easier when it comes to picking stuff out. And I like things when they're easy. All right, we all good? Great. All right. So make sure you save the text file. If you don't save it, it doesn't mean anything. Kind of like if there weren't pictures, it didn't happen. So save that. I'm going to close that out, and we'll get back into this. Okay. So let's get ourselves an array of data. So here's a new command for you. You want to write this down somewhere because I'll be flipping back to another screen in a minute. So this is a numpy command, or a command from the numpy library. So you know offhand that you'll have to make sure that you import numpy when you start the code, and the command is load text, or load txt. Yeah, it's called all that this command does is load numbers from a file, which is a really important distinction. It does not load words. It only loads numbers. Numbers and numbers only. Okay, that's it. So when we go to use this, something that we're going to, excuse me, something that we're going to have to be really careful about is that we have words and symbols in these different text files that this will not be able to read. In fact, it'll freak out and crash if we try. I mean, it won't crash your computer, it'll just stop your code. So we're going to have to be very, very careful about that. That said, it's a really, really handy tool. It's very flexible. So this is how it works. you have, it's called, you have in this explanation here of how it works, everything inside of the parens is what you can put into the function, same as the print function, right? You have print, open paren, everything that you want to print, close paren, right? Straightforward. Same thing here. Everything you put into the functions is between these parentheses. These square brackets, all which called, they're not something that you actually write. They're just there to mark optional statements or optional arguments in the load text command. I could just put a file name in. This file name stands in for the string, the name of your file in quotes. If I just put that in, this might work. But depending on what my file is, I might need to use some additional options in order to get exactly what I want. And that's what these optional arguments, or the ones that are in square brackets, that's what those are there for. Again, you never have to write the square bracket. It's just there to mark what's optional and what's not, okay? You pick and choose what you want from this list of arguments. Does that make sense to everyone? Great. Well, I saw at least one person on the other head. Make sense to everyone else? Great, okay, cool. So let's give this a shot. I need PowerShell. Okay, it's gonna take me a minute to navigate here. So pardon me for a second. Make this bigger. Okay, so I'm in g:\/ my drive. It's a few. Okay, oops, right, there we go. Okay, there we go, great. Just want to make sure that I was in the right place. Okay, so this is my, this is my folder. I'll put my Python file here. It's the same place. It's in the same place as welllog.txt and my nrel-data.txt. So load text example.py. There we go. Alrighty then. So this is going to be an example of using load text to obtain data. First thing I'm going to do is I know that my command's a numpy command, so I'm going to import numpy as np. Brandon, would you mind turning off one of those two light switches so it's a little dimmer, please? Thanks. It helps a little bit. Thank you. Okay, so that's the first thing. Next thing is that I'm going to I'm going to load up the text. So when you use the load text command, it creates an array of all the values in that file. And you have to save that somewhere. Same as if I write 5, I can't just have 5. I have to have like a variable equals 5, right? I have to save it to a variable. So when I have the load text command, I'm going to say np.loadText is equal to something. In this case, I'm just going to say data input because I think it's a nice file name. And then I'm going to grab the nrel data. It's nrel-data.txt. Okay. Now, let's see if I can pull this up at the same time. Actually, oh, I can be fancy. Hang on. Okay, so this is this is nrel-data.txt, right? This is my this is my Python file. Two separate files. I just have them both open at the same time. So I said that load text can only load numbers, right? So if I loaded this file as I see it now, it would die. So because there's text at the top, and it would try to load that. We can run that quick, see how it goes. Uh, and it says, what the heck? That's a rough translation of all this text. The important ones to note, again, the end of the error message is usually the one that explains it. And it says, it's called value error, could not convert string to float. Remember, float is a number, string is not a number, it's a character, right? It's saying that it can't read the character because that's not what load text 66 does. So let's go and fix that. Pull up the ML. Okay, so I could just delete these first two rows and my life would be great. But then if I open this text file later on, I don't know what's in here, right? Like there's value to having these first two lines, and I want to keep them if I can. So it'd be awfully nice if there was a command for load text that just let me skip some rows. And well, gosh darn it, if you remember from that slide, there was a command that said skip rows, right? And what it does is let you skip rows. So yeah, is there? Okay, yeah, isn't it awesome? So I'm going to add an optional argument to this load text command. I do that by just adding a comma and just start typing. The name of the command was skip rows, and how many rows should we skip? Dumb question, I know. 2. So we're going to skip 2. There's 2. So I've told it load nrel.data.text and skip rows is 2. So you're going to skip. It's going to skip 2 rows before it tries to read anything. It says if I commented these out and they didn't exist, it's going to ignore them entirely. Anything that I want could be on those lines, and it won't care. I'm also just going to add one more thing, just print data input, so I just know what's going on, right? So I'm going to do that, close all that out. There we go. So this is all the data that was in that text file. Someone got something like that going on? Great. All right, and yeah, it's in scientific notation, but that's fine. So we can read data in. Now, something to note: look at this number. Look at what's going on. What the crap's with these square brackets here? This isn't like any number that we've seen before, like any output we've seen from Python before. And that's because it's an array. It's all saved to all these values are saved to one number, or saved to one variable, sorry. And that's because they're saved as an array of numbers. Or if you remember matrices, if you've done any linear algebra, you can think of this like a matrix. Okay? So we need to parse this somehow. So, at least for me, the easiest way that I've ever seen to do this is to try to understand it with like XL. So I'm gonna pop this over to one side of the screen, pull this over to the other side of the screen. Okay, so if I had this in Excel, it would look something like this. 8, 9, 10, 11, 11.4, 12, 13, 0, 7, 18. I can't write. 271, 3, 25, 6, 4, 2, 521, 534, 513. Okay. If I had this in Excel, this is what it would look like. And this is kind of what an array is. It's a whole bunch of different cells, if you will. Each one has its own, and each one has its own address. It's a quick question. Do you guys need help getting something? It's not running for you. Okay. All right. So let's have a quick look here. So in downloads array practice. Let's just double check this first. Programming arrays. Okay. So do a quick check. Okay, it is found. Oh, that's it. See where it's enroll capital D data?
Oh, okay.
Yep.
Okay.
Yeah. Because you have load text and it's load txt. Yeah. So, yeah. So spelling does count here. So this has to be the exact name of the file. What is the exact name of the file? Yes. So nrel_data.txt. And it also has to be in quotes. Because else it's it's not a name, it's just a word started at the front. Yeah. It's trying to be helpful, but it doesn't know what you're trying to do. Cool. And then you have to add the skip rows thing and all that. Skip rows. Let me just open that up again so that you can grab it. Yep. Okay. Let's have a look. So the .text thing is really important. Windows hides file extensions by default, which is kind of annoying. Well, let's have a look at that. Okay, so this means that it's not in the same directory as where this is. So users SFU untitled 6. Can you go file save as? Yep, and save it in the same directory as NRL data. Yep. Yep. So run that and see what happens. There you go. Okay, and all right. So just for kicks and giggles, go file save as and make sure it's in the right place. So it's inside of programming arrays, right? Okay. I'll just save it again just for kicks and giggles. Okay, that one's right. Okay, let's run that. All right. Okay. Well, let's make sure that you're saved in the right place. Remember I was saying about saving it all in the same location. Let's go up here, go to File, Save As. Yep. No, that's a new file. Save As. I'll put it in the same place that text file is. Oh, you don't see the text file there. Okay, so save there. Whatever name you want. And make sure that's Python. Sorry, can you click it for me? Thanks. Yeah, Python. Yeah, and save that. You just call it. Don't worry, you're in the right place because we saw it over there before. Let's hit play and let's see what happens. There you go. So it's working for everyone. Great. All right. So just remember that in order for this thing to work, your file has to be saved in the same location as the program you're using to open it. All right. Cool. All right. So back to our regularly scheduled program. So you get you get values that are in an array. An array is just a set of cells. It's a structure that holds different bits of information. So each cell has its own address. So if I was to start writing addresses here, nice if they didn't start with white. There we go. Although the first one, this upper left-hand corner would be 0, 0. It always starts at 0, 0, and this is exactly what you think it is. Rows and columns are X and Y, however you wanted to think about it. The first one is always rows, second one is always columns. All right. So that means that if I go over to the second guy here, that means that its address is 0, 1. There's 3 here. Address is 1, 0. 47. Address is 1, 1. And so on and so on and so forth. Make sense? Sweet. So if I was to go over my code, hey, stop it now. If I was to go over here and I wanted to print, say I wanted to print just this 47. That's what you call it. Its address is 1, 1, 1. So I can come over here and instead of saying print data output, because data output is the whole array, I could say print square bracket 1, 1. The square brackets are how Python knows that you're entering an address. So it's going to look for cell 1, 1 in the array data input, and it's just going to print that. So do that. Python oh, right. So that. Let's see what I'm printing here. Did I get really dumb? Okay, no, good. Okay, I just missed a number when I wrote all these in. That makes you feel a lot better. So that's 1. So that's 1. So that's 1, 1, right? That's our first one. That's 0, 0. That's 1, 1, and it printed 1, 1, 1, 1. I should have wrote a 0 in where I wrote 40. Let's call it 47 here. Transcription error. All right, makes sense to everyone? Cool. All right. Let me just correct this while I'm thinking about it. What? 5034. There we go. 0, 0. Okay. So which call, and I can follow that same logic if I wanted to print out anything here. So for example, if I wanted to print out the set, which called the 7, if I just wanted to access that, what would the address of that 7 be? Yep. Let's see. So 1, 2, 3, 4, 5, 6, 7, 0. Okay. Who agrees with that? Okay. Well, let's give it a shot. There's 7. Oops. 0. Wow. Not doing too well right now. There we go. What? That's not quite what we expected. Why? It is 7 from the top. 1, 2, 3, 4, 5, 6, 7. but what's our first one here? 0, right? So it's 0, 1, 2, 3, 4, 5, 6. It's something that's it's really easy to get tripped up in, but conveniently, it's the same as the range command, right? Range starts at 0 normally, so it's a kind of nice thing in Python. Everything's kind of uniform. Everything always starts at 0, unless you tell it to do otherwise. So that's reading from an array. But we can write this way too. So say I have data input. Let's say that I want to want to multiply every one of these values by 2. Or I want to pull it out, multiply it by 2, and put it back in, or do something else. Whatever. Let's give this a shot. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 rows here. So if I wanted to access every one in a loop, I'd have to run the loop 14 times, right? So I'm going to say for I in range, wow, I can't spell, 14. That means that my loop will run 14 times, right? And I will go from 0 to what number? 13, right. And what's the highest value, and what's the highest row number in this array? 13, right. So it's perfect. So instead of writing out a number for the array address, I'm just going to put I in, because I know that it will be every number from 0 to 13. I'm going to save that as row value. I'm going to save that value that I pull out of the array as row value. Let's just print that and see what we get. Okay. So what I'm doing, just for quick recap, I pull in all the data. That's where I get data input. That's where I get that array. Then I go into this for loop. It's going to spin around 14 times. Starts with I equals 0. So when I come over here to data input, it starts out at 0, 0. Takes that value, saves it as row value, prints it, comes back up. I is now what number? It was 0, 1. You're right. Comes back down here, grabs data from 1, 0. 1, 0. Saves that to row value, prints it. I is now 2, so on and so forth. Cool? We feeling pretty okay about that? Okay, so save that off. There we go. So it went into our array. We've gone into the array. We've grabbed the first value, printed that, second value, printed that, third value, fourth value, et cetera, et cetera. So now we know that we can take information out of an array, and once we have it out of the array and saved as a variable, we can do whatever the heck we want with it, right? So if I wanted to go back into my code and say, this is value that I take out, I want to multiply that by 2. I can do that. And there we go. I can square it, I can multiply it, I can square root it, I can do whatever the heck I want with it. It's now a number that I can work with. So this is pretty sweet now. I can load up data and I can do math with it. I can manipulate it, and if I want to, I can save it right back to where it came from. So I'm going to specify which address to put it back into, and tell it what value to put there. So I have the value to put there, have an array with a particular address, and I'm going to save it there. And then I'm just going to after the loop's done, I'm just going to print data input. Actually, let's do that twice. Do it right before and right after, just so we can see what the difference is between those two. I'm just adding that print statement in the middle that has nothing in it. That all that's going to do is create a blank line. All right. All right. So if I run that, oops, if I run that, there we go. There's my initial array there. I can scroll down. I can see that all the values in that first column have been multiplied by 2. So I've taken data out of that array. I've done math with it. I've put it back into that array. And it's called and it's all just worked really, really nicely. Honestly, I actually did an extra step in there. Instead of doing this in 2 separate lines, I could just do it all in 1 line. Say data input I, 0 is data input I, 0 times 2. It's the same thing. How are we feeling about that? Yes, no, maybe. Is it working for you? Is it working for you? All right, great. All right. So that's the start of arrays. Let me make sure that that's right. Okay, we got that. Oh, yes. Okay. So now for how to shoot yourself in the foot with arrays. So back up here, add some comments. So for this particular problem, it's straightforward. I know how many elements are in this array because I can just count 14, right? That's easy. A lot of times we don't know how many elements there are in the array, or it changes. If someone tells us how many that we have, that's easy, right? I just come up with a variable, stick it in there, and we're all done. But it's going to be nice to be able to say how big an array is. So let's play this game. I'm going to shift over to my interpreter. So your IPython console. I don't know if your console will do it just because of where Spider is on your computer, but it's called the structure will be is the same wherever you use it. So I'm going to grab my MREL file again. Okay, there's data input. Same as before. So I'm going to try this time is I'm going to make another variable, size of array equals input data dot shape. Oh, data input. Here we go. So it's just name of my array dot shape. That's it. Now, if I look at size, the variable size of array, it says 14.2. And what does that match? What does that match up with? Right, it matches up with the dimensions of my array. So if I do this thing, where I ask for the shape of my array, I can get it. I can get the total number of rows, total number of columns. If I want to grab just one of those and say, make another variable, say total rows equals size of array, And do I want the first line, the first guy in that, or the the second one? Because this in and of itself is also an array, right? It just only has one dimension to it. So we only need one index, right? I only need one address number. It's either going to be in the first one, the second one, the third one, the fourth one. There's no second dimension. So what's the address of the rows in this array 14, 2? You can think of each number as its own element in the array, as its own cell. What's always the address of the first cell? 0, right? So the address here of number of rows, or the 14, is just 0. That's it. There's no second dimension because there is no second dimension. It's all one. It's all just one row of numbers. Okay. So I can grab a bit like that, and if I check total rows, it says it's 14. Cool beans. So now let's do this back in our code. So instead of just putting in 14, let's get how many rows there are in whatever array that we pull in. So say array size equals data input dot shape, then total rows equals array size. We know that the rows are always the first one. Rows are always the first variable in that shape array. So we'll just use the first element. And then instead of writing in 14, I'll write in total rows. And so I can see whether or not it worked. I'm going to print data input at the end. All right. We all caught up to there? All right, so quit out of that. There we go. So it's done all my work for me now. I've automated the entire process. Just sweet. This is where I want to be. Okay. Now, what happens if I used a for loop here. I can also do this in a while loop. So let's have a look at that. Wait for it. Wait for it. And there we go. All right. So, while loop. So let's have a look at this. In this case, I've hard coded how big my array is. So I come down and say my array is going to be 6 long. And I use this command np.zeros. All that does is make an array of zeros. That is however many long. So in this case, I have 6 zeros chilling out in a row. If you want to see it, it would look something like this. 2, 4, 5, 6. That is 6 zeros are not like 6 sixes. Sorry. Let's try it a second time here. 0, 0, 0, 0, 0, 0. So that is my array. The address of this guy would be what? 0. Address of this guy would be 2. Address of this would be 5, right? Because it's the last one in a 6-element array. 0, 1, 2, 3, 4, 5. Okay. So that's my array. Okay. I come over here, set I equals 0. Okay, so the first time through, I is 0, array length is 6. That means that I is less than array length, right? So this is true. I go into my loop, I print the first value in the array, which is 0. Come down here, I is now 1, still less than 6, another 0, 2, still less than 6. What you call I is 3 at this point. Sorry, I is 2 at this point. 3, 4, 5, 6. Is this still true? No. So it pops out and I'm done. This was less than or equal to. It would be true though, right? We come down here. What's in array 6? Array element 6. If you're perplexed because there's nothing there and it doesn't make sense, you're right. There is no array element 6. So let's see what Python does in this case. This is probably the single most common error that you can possibly make with arrays. So just for kicks, I'm going to add 1 to that for loop. So it should be going 1 and looking for 1 more row than is in my array, right? When it does that, it comes back with this error. It's called an index error. Oops. I want a mouse. Thank you. And remember, you go to the last thing, and it says it's an index error. Index 14 is out of bounds for axis 0, size 14. Yay! That's low. That's low. That's a load of crap. Well, let's parse this. So axis 0. Remember, we always start at 0 in Python. So if this is an axis, and that's an axis like an x-axis and a y-axis, that's the first axis. So it's axis 0. Okay. So we're talking about that. So we're talking about that number there. We're saying, which is also called an index along that axis. And it's saying index 14. So it says you put a 14 in there, and it's out of bounds. Out of bounds means that there's nothing there. You've gone beyond the end of the array, and there's nothing. Try call. I can't give you anything because there's nothing there. And that's what this error means. It means that he tried to access something that wasn't there. The reason why he did it can range from something like this while loop, where your condition change allowed you to go to the wrong place, or like that for loop, you just put in the wrong range. So for an error like this, it's useful just to go back through your code, go step by step, and see what the values are. Okay. Any questions on that? Questions on arrays? Awesome. They're the most useful thing in the entire world. Enjoy. In fact, for your array using pleasure, there'll be a homework out with all sorts of fun array problems for you. Aren't I nice? All right. Thanks for stopping by. That's all I got today.